Let's go ahead and do some rate conversion from the 7th grade chapter 6 text. The first thing that I want to look at is a set of really simple ones. So if we saw a problem like this that said, a snail, that is terrible handwriting, I'm sorry, travels 5 feet in 1 hour. How many inches? Per hour does he travel? Okay, so let's look at this one. The first thing that I want to do when we are doing rate conversions is we actually have to set up the 2 units that were given, or measurements that were given, as some sort of rate. So, knowing this, let's look and see what we have. We know the distance that he travels is 5 feet, and we know the time in which he travels it is 1 hour. So let's set that up. 5 feet over 1 hour. So in 1 hour, our snail is able to travel 5 feet. That's a pretty fast snail, I feel like. Anyways, we want to know how many inches this snail is traveling in an hour. So this is the type of conversion where we are only changing one of the units. Which unit are we changing? If we're trying to go to inches per hour. So I'm going to go over here on the right, and I'm literally going to write down exactly what I'm looking for, what my end result should be. I want inches in 1 hour. How do I know that? Because that's what the question is asking us to find. How many inches in 1 hour? And we see this slash mark here, which is going to be the same as our division symbol, which looks the same as a fraction bar, which is also said to be per, for, in. All of those are going to tell us that we need to set it up as a rate that looks like a fraction. So now, looking at what I have according to the problem on the left, what is changing to get to my answer? Well, if I look at hour and hour, those are the same. Okay, so there's nothing that I can do about that. That's exactly the way that I want it to be. Feet is in my original problem. Inches is in my answer. That's the difference here. We're changing feet into inches. In order to do that, I need to know how many inches are in 1 foot. So I say, if I'm going from feet to inches, how many inches are in 1 foot? Well, I know if I pick up a standard ruler, there are 12 inches in that ruler, which is a foot long. So there are 12 inches in a foot. I'm going to write that. And we can see, based off of the question that's being asked, that they want inches as the numerator. And they want hours as the denominator. How do I know that? Because that's the order that they listed them in. Whenever we read fractions, we always read the numerator first, and in this case, inches. Or with rates, inches per hour. Hour is said second, so it is on the bottom, is in the denominator here. Okay, so here's what we're going to do. We're going to write down our 12 inches in a foot. We have to write it as a rate so that we can actually cancel some things out. And when we're canceling, basically we're saying that because there's something on the top, we can get rid of it. Because there's something on the top and the bottom, we can get rid of them. That would kind of be like multiplying by 1 and then dividing by 1 at the same time, which really is a waste of time because you're going to get the same answer anyways. So I know that there are 12 inches in 1 foot. All right. What we're doing here is we're multiplying. We're multiplying because we want to try to convert something, and in order to convert it, We are going to set up two different rates and combine them together with multiplication. So now, looking at this, we have two things that are similar. And when we cancel something, we cancel it from the numerator and the denominator. So we're looking for matches between the numerator and denominator here. So let's look. I don't see any 5s in the denominator, like the 5 that's here. Feet, what about feet? Because we can look at our numbers, our values differently, our numerals differently than we can look at our measurements here. So feet and 5 are going to be two separate things when we're talking about cancellation. And I know that sounds strange, but bear with me. Feet, oh look, there's feet on the bottom. Well, if I multiply by feet and divide by feet, then it's going to be just a waste of time. So I can get rid of feet. They can cancel out here because there's one on the top and one on the bottom. All right, 12. Nope, we're good. Nothing on the bottom that says 12 inches. No, we're good. Nothing on the bottom that says inches. All right, let's go down to the bottom. 1, no 1s on the top. We can't cancel anything. Hour, no hours on the top. Can't cancel anything. What are we left with? I'm going to rewrite our problem. We are left with 5 times 12 inches. One hour times 1. Here we go. Now we can actually solve this. 5 times 12, we're multiplying across. 5 times 12 is going to be 60. The only measurement that's left here is inches. Ooh, look at that. 1 times 1 is 1. The only measurement that's left here is hour. So our snail is able to go 60 inches in 1 hour. Is that what we were looking for? Yes, if we go back to the question, it says inches in an hour. So we have changed feet to inches, multiplied across, and ended up with this particular rate. This works perfectly if we can get rid of the common pieces. All right, let's look at another one. And just for the sake of, let's go back actually. Just for the sake of understanding this, I would like to draw you a quick bar model here. This was 1 hour. This was 1. I'm going to draw you a quick bar model up here in the middle. So that we can get a visual of what's happening. So I know that he's gone 5 feet, all right? Here's 5 feet. 1 box for every foot. And all of this is in 1 hour. I want to change this into inches. So if this is 1 foot, it's also 12 inches because those two are the same exact thing. They measure the same amount. If this is 12 inches, then this foot 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 is 12 inches. In order to figure out how many inches he's gone in an hour, because this is an hour, we can add all of our 12s together or multiply by 12. Let's do another simple one, and then I'm going to give you a harder one that's from the book. So a slug, this time, travels 48 inches in, let's say, per hour. How many feet? Boop. Per hour did he travel? All right, so same thing as before. We're looking for whatever rate we've been given, and it says 48 inches per hour. So I can set that up as a rate. 48 inches per 1 hour. All right. So now, what am I looking for? What's my final goal here? We need to know how many feet per hour he goes. We want feet per 1 hour. All right, so here we go again. We're looking at our problem and we're saying what is changing. We have feet, or we have inches, excuse me, that the ultimate goal is feet. Oh, that's different. Okay, well, what about the bottom? Is that changing at all? Hour turning into, oh, nope. Hour and hour are the same. So the only thing that's changing here are inches to feet. So then we ask ourselves, inches to feet is changing. How many inches are in a foot? If I'm going from inches to feet, how many inches are in a foot? There are 12 inches in 1 foot. I would like you to notice something. Foot, I have placed on the top of my rate. The reason I placed it up there is because, one, we're asked to find feet per hour. Feet is mentioned first in that rate, so I want it to be on top. Secondly, I know for a fact that if I have a measurement on the top that's the same as a measurement on the bottom, that I can cancel them out. That they can totally disappear because I have one on the top and I have one on the bottom, because I'm basically multiplying and dividing by the same thing. Let's give it a shot. All right, so I'm going to go ahead. I'm going to find what I can cancel. I already know that I have two different things here that I can cancel. I have an inch in the top that can be canceled with an inch on the bottom. It's kind of like adding a positive to a negative or a negative to a positive. They end up canceling out. They go back to nothing. And we are left with 48. That looks like a 9. 48 times 1 foot and 1 hour times 12. Okay, so now let's see what we end up with. 48 times 1 feet is the only option to have as a measurement. 1 times 12, 12. 48 feet over 12. Now, this is where you have an additional step. This does not give you the unit rate. We want the unit rate having 1 on the bottom. So what we have to do is we have to go ahead and we have to divide. We have 48 over 12, which is the same as an improper fraction, which we always, unless asked not to, are going to simplify. So 48 divided by 12. If I count by 12s, 12, 24, 36, 48, I'm dividing both the top and the bottom. I'll rewrite it here so we have a little room. By 12. Four, drag my measurement down, feet. 12 divided by 12 is 1. Drag my measurement down, hour. 4 feet in 1 hour. Poor slug. All right, let's look at the last one that I have for you. It is a little bit harder. Here we go. Ooh. All right. The maximum speed of a McLaren is 110 kilometers an hour. Here's what we need to do. A, express the speed in meters per second. B, using 1 kilometer equals 0.62 miles, express the speed in miles per hour. Two separate problems. Let's go ahead and do it. First things first. We are going to express, which means rate, the speed that we have in meters per second. Let's create a rate. Going back to my problem, I have the speed of 110 kilometers an hour. I'm going to write that. 110 kilometers in 1 hour. Okay, cool. So the next part says, express the speed in meters per second. What am I trying to get to? I'm trying to get to meters per second. This is where it gets interesting. We're going to see what is changing here. We have kilometers on the top of our original rate, and it is changing to meters. Whoa, stop there. We're already changing one thing. Take a look at the bottom. We're going from hours to seconds. Whoa, that's two things that are changing. That's to show you that this is going to be a two-part problem. You can choose one to do now, or we can set them both up at the same time. I'm actually going to go ahead and I'm going to do one at a time, just to show you how to do it that way. So I'm going from kilometers to meters. That's what I'm going to choose first. So I'm going from kilometers to meters. I'm going to ignore the hours to seconds for now. So I need to know, if I'm going from kilometers to meters, how many meters are in a kilometer? Well, the abbreviation or prefix kilo means 1,000. So there are 1,000 meters in 1 kilometer. Notice I wrote meters on the top because our answer is looking for meters on the top. And also, I wrote meters on the top so that I could cancel out kilometers in my actual problem. Kilometers, the same as kilometers. Remember, that only works when they're diagonal or when they are one on the top, one on the bottom. Okay, so I have 110 multiplied by 1,000. That's the top. Oops. Oh, thank you. 1, 2, 3 zeros. That's going to be my answer. So I have 110 multiplied by 1,000. It's 110,000 meters. How do I know it's meters? Because that's the only thing that's left on the top. Now let's look at the bottom. 1 hour times 1. 1 times 1 is 1. And hour. Woo! Now let's go back to look at our regular goal here. Our goal of this problem is to get to meters per second. Step 2, we're changing hours now. How do I know? Because I've already changed the top part. Now I'm going to look. I'm comparing my measurements. Meter to meter. Perfect. That's fine. There's nothing we're going to have to do to that. Now the bottom is hours to second. Ooh, that is something that we're going to have to do something with. So I need to figure out how many seconds are in an hour. There are 3,600 seconds in an hour. Oh, look at that. I'm already doing it wrong. I need seconds to be on the bottom. Why? 1, because seconds is on the bottom in our answer. They're expecting it to be on the bottom. 2, because there's already an hour on the bottom of our first fraction. I need there to be an hour on the top on the second one so that they can actually cancel. Let's do that. All right, we are left with 100 and 10,000 meters times 1 ends up being the same. 1 times 3,600 seconds. Let's go ahead and divide. Why are we dividing? Because it's an improper fraction. Or reduce by the number, or the greatest common factor here. In this instance, I've showed you this before, but I will show you again. If you have an answer that ends in zeros on the top and the bottom, remember we've been talking about canceling. I have 2 zeros at the end of my number here that can cancel the 2 zeros on the end of my number here. So this is an equivalent fraction already, which means we'll end up with the same answer when we divide. 1,100 divided by 36 ends up being 3. That's 108. We subtract, you end up with 2, 0. 36 goes into 20, 0 times. So we subtract, we're left with 20. I'm going to write this as a fraction. 20 is my remainder. Over 36 is my whole. 20 over 36. And that can reduce down to 5 over 9. So 30 and 5 over 9, because I can divide both of those, the 20 and the 36, by 4. And that is meters per second. All right, the next part here, they're asking us for B. If you go back and you look at B, it's asking us to go from miles or to miles per hour. And so we're actually going to go backwards. We're going to go back to our original rate, which was listed in the problem up at the top. Oh. As 110 kilometers an hour. This is the very last part of this problem, and you are good to go. 110 kilometers in 1 hour, according to this part of our problem. And we want to express or write the speed in miles per hour. What are we trying to get to? We're trying to get to miles, MI, in 1 hour. Now, it's telling us exactly what to use because it's kind of an obscure measurement conversion here. 1 kilometer is the same as 0.62 miles. So what are we doing? We're trying to go from kilometers to miles. That's the only thing that's changing. Hour is still hour. So let's set it up as miles to kilometers. How do I know that miles is on the top? I know miles is on the top because 1, they're asking us for miles over hours. 2, there's already a kilometer on the top and I want to be able to cancel it. So I need a kilometer on the bottom. And 1 kilometer is how many miles? 0.62. All right, so now we can go ahead and we can cancel kilometers to kilometers because there's 1 on both. And we will go ahead and multiply across. We have 110 times 62. 0.62, excuse me. Times 0.62 for the top, and that ends up being 68.2. And then miles for the bottom. Excuse me, hour for the bottom. 1 times 1 is 1. Hour is the only part that is left. Oops, sorry, I forgot miles here. 682 miles in 1 hour.